we're talking about 8.5 dividing radical expressions. All right, just to warm up right here, I know we did this like in a previous section right here, but right here we're talking about quotients right here, and this is a quotient right here of square root of 54x to the fifth y to the third over square root of 3x squared y. So in this case right here, specifically, when I see that right here, I know that 3 actually can go into 54, and we have obviously right there x, and we have right there y in common right here. I would just put this all under one single radical right there. Okay, and this way we could actually simplify inside the radical. Now right here, 3 is going to go, of course, into 54 18 times. And then right here we have x to the fifth over x squared. All right, remember we're subtracting in this case right here. So 5 minus 2 is 3, so that's x to the third. And then right here we're, of course, subtracting right here. Y to the third over y to the first is going to be y squared. So don't forget right here, if it's just a coefficient, I'm actually dividing like I just did right there. But when we have powers with the same base, in this case right here, we were subtracting the exponent. Remember, I could do that because we had the same base. All right, so right here we have the square root of 18x cubed y squared right here. All right, so let's go and separate this guy out. No problem. Square root of 18, I know that's going to be root 9 times root 2, which is 3 root 2. So I'm going to write down 3, and then over here I'm going to write root 2. Okay? So that one is done. Now we have square root of, we have the square root of x cubed. Okay? Well, we know right here, if you think about that, that's like 2 into 3. 2 divided by 3 is going to go 1 time with a remainder of 1. So that's going to be x, and then the remainder right there we're going to put underneath the radical, square root of x. So we'll say x right there, and square root of x is right there. That one's done. Then we just have next right here, we have the square root of y squared. Okay, and that's like 2 into 2 goes 1, so that's just going to be y to the first. And there we go. There's our answer right there. Okay. Some people prefer to do it as rational exponents, so if you want to see it that way right here, but this is the true answer, just leave that on for a second. Now right here, remember at that previous example I was showing, if you have the square root of y cubed, some people don't, like thinking about it of like, dividing, but they prefer to think about it like this. We have y to the 3 over, now remember the index is 2 right there, or the root is 2. So it's y to the 3 over 2. So what does that come out to be? Well, I know that's like 1 and 1/2, so that's y to the first times y to the 1/2, which is basically y, and then the square root of y. And then you could do the same thing that I did over there, right? Same, right? So just letting you know that's another option. But some people indeed do like the way I did it right here, where I'm just kind of thinking about like dividing 2 into 3, 1, remainder of 1. Rationally, the denominator is the process of converting a fraction with a radical in the denominator to an equivalent fraction whose denominator is an integer. So when I'm using the term rationally the denominator, what I'm doing is, like, if I have 1 over the square root of 3, and we're going to find out in a second what that's going to end up being equivalent to is the square root of 3 over 3. Look, I just rationalized the denominator. That means that right here is the equivalent fraction, but right here the denominator is now an integer. Okay. A simplified radical expression is a radical expression is considered simplified if there are no factors in the radicand having perfect powers of the index, no fractions in the radicand, no radicals in the denominator of a fraction. Okay, So let's take a look right here of some examples right here. So we have 1 over, actually let's look at some more basic fundamental examples first, and then we'll look at the other ones. One second, here we go. All right, so we're going to rationalize this denominator right here. So we have 10 over the square root of 6. So to rationalize, what I'm going to do is I happen to know, remember right here, that this is a square root. So square root times a square root times the exact same square root is just going to be whatever's underneath the radical right there. Okay, so that's just going to equal 6 right here. And likewise, don't forget also, like let's say it was like the cubed root of 6 right here. Well, to make that an actual, the actual number that's underneath the radical right there. Okay, so to get rid of what we'd want to do is we're going to say, okay, that's going to be times the cube root of 6 times the cube root of 6 right here. So that would give us 3. So if you think about that, what that's going to mean right here is like the cube root of 6 times the cube root of 6 squared, okay? If you think about that right there, okay? Anyway, let's keep it simple though. So in this case right here, we're only talking about a square root. So that means I'm just going to go and multiply this by the square root of 6. Now I can't just multiply the denominator. I have to multiply it by a fraction that's equivalent to 1. Root 6 over root 6 is 1. So that's going to give you 10 root 6 over root 6 times root 6. We just said is 6 right there. And then we'll go ahead and simplify right here. We have 10 over 6. That simplifies to 5 over 3. So 5 root 6 over 3 is going to be my answer right there. Okay. Now, don't get intimidated just because you have a x right there, a variable. That doesn't matter. But still, root 5x over root 5x. So what's that going to be? 10 times root 5x. And root 5x times root 5x is just going to be good old-fashioned 5x right there. And then don't forget we have to still reduce. We have 10 over 5 right there. So that's going to reduce to what? 2 over 1, right? 10 over 5 reduces right there to 2 over 1. And that's root 5x is still there. And regular old x is still right over there, right? Okay. So, of course, you don't need that 1 right there. So that would just simplify to 2 root 5x over x. And there's nothing more I can do. Don't make any mistakes right here. Remember, square root of x right here, that square root of x and that x right there, don't have anything in common. So you leave them alone right there. I mean, one of them is like the square root of x. The other one is just like x to the first. I mean, I shouldn't say they don't have anything in common, but you don't cancel them out right there. You're just going to leave this like this right here. Okay, so there we go. We rationalize the denominator. Let's look at this guy right here. Times square root of 6q times square root of 6q. That's going to be 18 root 6q over 6q. And then right here, of course, we have 18 over 6. That's going to be 3 over 1. Right there. And then right here, I just want to change colors real quick so you can see I'm doing something different. And then right here, so we have, this comes out to right there, 3 over 1. And then right here, we'll just carry over the root 6q over q right there. Okay, this is technically correct, but you don't really need that 1 right there. So we'll say 3 times 6q over q. And we're good right there. Okay. Okay. And by the same token right here, I just want to show one that's like a slightly different right here. What if it looked like this right here? So if you see right here, we have 1 over the cubed root of 2 right here. So just like I showed before right here, okay, we're going to go and multiply that by right here. Remember, as I said, we need to say cube root of 2 times cube root of 2 comes 2 cube root of 2. So you need it like 3 times. Okay, so I'm just going to go and say, okay, that's the cube root of 2 to right here, the second power. And you can write that in parentheses and the power outside, or you can write it like this. It doesn't make a difference. But that's going to end up with what? The cube root of 2 to the second power. And that's going to end up just being cube root of 2 times cube root of 2 times cube root of 2, like this. Think about this. That's just going to be 2. All right. Good old-fashioned 2 right there. So there we go. So that ends up being right here, the cube root of 2 squared over 2. And we're done. And remember, you could also, if you're writing this as a rational exponent, that would be 2 to the 2/3 over 2. Okay? But, if you're rationalizing the denominator, you would probably just keep it like that. Okay? Just wanted to show that right there. Let's go on to the next problem. Okay, so right here, let's look at an example right here. Rationalizing a 2-term denominator. With a denominator of a fraction is a sum or difference with square roots, we use a product of conjugate patterns to rationalize the denominator. So what I'm trying to say right here is that just recall, if we have 2 minus root 3, when we multiply that by 2 plus root 3, we're going to end up right here with we're going to end up rationalizing this. That means there's no longer going to be a radical. There's no more radical here. Okay? Because look what happens right here. We have 2 times 2 is 4. We have 2 times root 3 right there, which is going to be, hang on a second, is going to be right here 2 root 3. We have negative root 3 times 2 is going to be negative 2 root 3. And negative root 3 times positive root 3 is just going to be minus regular old 3. Okay, remember root 3 times root 3 is regular old 3. And that's a negative right there times a positive, so it'll be a negative. And then we simplify over here. 2 root 3 minus 2 root 3 cancels out, so we have 4 minus 3, which is 1. So this is kind of like, the same concept of a plus b, a minus b, right? When you're factoring a squared minus b squared, so a difference of 2 squares. Same concept right here. The middle 2 terms cancel out. All right, so let's take that concept right here and do a couple of examples. All right, we have right here 1 minus root 5. Let's do it. Okay. So we're going to go ahead and 8 over 1 minus root 5. We're going to go and multiply that by what's called the conjugate. And the conjugate right here, if we're talking about a plus root b, the conjugate would be a minus root b. If we're talking about a minus root b, the conjugate is going to be a plus root b. Okay? Get it right there? That's what the conjugate is going to be. So right here, we're going to multiply both the numerator. Let me write that down over here. We're going to multiply the numerator and denominator by the conjugate. Now, don't forget, why we have to do the numerator also is because we're basically multiplying the fraction by 1. Okay, so we're going to say right here, like I just said, 1 plus root 5 over 1 plus root 5. We're multiplying this by 1. This fraction right here is equivalent to 1. So that is legal. Okay, it is okay to go ahead and multiply that right here, this by 1. You can multiply any fraction by 1, and everything is okay. It's still going to be equivalent. So that's why we're doing it. That's why we're doing both the numerator and denominator. So let's do it. All right, we have 8 times 1, which is 8. We have 8 times root 5, which is going to be 8 root 5, positive. Okay. Now, same situation, what we just showed before. We have 1 times 1, which is 1. Don't forget, 1 times root 5 and 1 times negative root 5 is just going to cancel out. It'll be 1 root 5, and that'll be minus 1 root 5. That's just going to cancel out. All right, and then right here we have negative root 5 times positive root 5 is going to be negative root 5 times root 5 is just 5. If you can't understand this, remember what's 5 times 5? It's 25. Well, the square root of 25 is, last I checked, 5. So that kind of made me make sense to you. Okay. So here we have 8 plus 8 root 5 over 1 minus 5. 1 minus 5 is negative 4. Okay. And right here, we're just going to go and simplify this so the negative is not in the denominator. So no problem right here. That means that right here, I'm just going to change that to negative 8 plus 8 root 5 over 4. Just put the negative right there on the top and make sure you put it in parentheses. And then we're just going to simplify it. That's going to be negative 8 minus 8 root 5 right here, because all I did is just distribute the negative here into there. All right, that just changes the sign, over 4. Okay, and almost done right here, but we can simplify a little bit more. Right here, we have what? All right, well, 4 goes into 8 twice, so that's going to be negative 2. 4 goes into negative 8 twice, so that's going to be minus 2 root 5. There we go. Negative 2 minus 2 root 5 is my final answer. And that's it. So just remember, you can, in your last step, you always want to ask yourself, like I say in class, can I simplify any more? So I'm just going to put an arrow right here. This is, I can still simplify. Okay? Because 4 goes into 8 twice. So that's negative 2. That's going to be negative 2 root 5, right? Which is where I came up right there. All right, let's do another one. Let's try number 8. Okay, right here. So, I'm sorry. We have root x plus 8 over root x minus root 8. So we're rationalizing, remember, the denominator. So we do multiply the denominator and numerator by the conjugate of the denominator. So we have root x minus 8. All right, I'm going to go ahead and multiply that by root x plus root 8. There we go. All right, here we go. Root x times root x is going to give me x. Root x times root 8 is going to give me plus root 8x. Root 8 times x is going to be, once again, plus root 8x. And then right here we have root 8 times root 8. That's going to be plus right here. And remember, root 8 times root 8 is just going to give you 8. Okay? Let's go ahead and do the denominator now. Okay? Root x times root x is just going to be x. Now we have a minus and a plus right here. So remember, that is going to cause right here the middle terms to cancel out. We have root x times root 8, and we have root x times negative root 8. That will just cancel out. So let's just go and figure out what the last term is. That's going to be root 8 times root 8. I'm sorry, negative root 8 times positive root 8 is just going to be minus 8. Okay. All right, let's simplify here. Okay, next, right here. So let's simplify this guy right there. That's going to be root 8x times, plus root 8x. So that's going to be x plus 2 root 8x plus 8 right there, all over x minus 8. And there we go. We're done. We can't actually cancel anything out right here. We're just going to leave it like this right here. Okay, don't get confused right here. Remember, some people are like, oh, well, no problem. I can just cancel the x out right here. No, you actually can't. Okay, do that right here. No different than if you have like 2 plus 4 over 2 minus 7. You can't just say, oh, what the heck? That's just 2's cancel out. No, it does not work like that. This would be 6 over negative 5. That would be 4 over negative 7. Those are two different values right there. So don't get confused right there. You just leave it like this, okay? All right, now I'll just close it up with one more example, and I think we'll be good there. So why don't we try, yeah, why don't we try this one? That's fun. So we'll multiply this guy by root m plus root 8 over root m plus root 8, right? Okay, this is going to give me right here, root 3 times root m is going to be root 3m. Root 3 times root 8 is going to be right here, root 24, okay? And we'll simplify that in a minute, okay? Then right here we have root m times root m is just going to be m. Don't forget, once again, we're multiplying by the conjugate, so those two middle terms will cancel out. So we don't need to do root m plus times root 8 and then root m times negative root. I'm sorry, I wrote this down wrong. I'm sorry. Let me fix this. My fault. I misread my own 5 as 8, so let me fix that real quick. Sorry about that. This is root m plus root 5, and okay, so there we go. All right, so scratch what I just did. Sorry about that. I misread the 5 as 8, so let's try that again. Root 3 times root m is going to be root 3m, and root 3 times root 5, I'm doing the numerator again, is going to be right there, root 15. On the denominator now, we have root m times root m is just going to be m, root m times 5, and root m times negative root 5. So root m times root 5, root m times negative root 5 is going to cancel out. We don't need to write it down. And then we have right here, negative root 5 times positive root 5. That's just going to give me minus 5. Okay? Okay, right here. Is there anything more I can do right here? Well, you look right here, root 3m. Not much going on there. I can't simplify anything there. Root 15, I don't think so. Root 15 only gives you root 5 and root 3. Nope. There's no perfect squares I can that divide into root 5 or root 3. So there's nothing I can do there, right there. And then m minus 5. So we are good right here. That's the final answer. Okay. I hope you learned something, guys. And that is about it. Thank you so much.